Welcome to the part 3 of the final week of blockchain technology and applications on NPTEL. So in this last part, I want to talk to you about some of the misconceptions I have seen while discussing about blockchain with various people, including the government agencies, and I want to dispel some of these myths so that you are also aware of those misconceptions and you know how to address them when you discuss the blockchain. So I have written down some of the misconceptions that I have been hearing about. So first one is blockchain is like the internet. You need to build a network infrastructure around the country or in a state so that everyone can use that infrastructure to do their e-governance and other applications. And I have seen this in Tamil Nadu government's brochure where they are claiming to be building a statewide blockchain and through which they want to provide e-governance services. Now, the problem is that blockchain is not like the internet. You don't have to pre-build a blockchain on which all kinds of data will be thrown in. You have seen that we did for example a blockchain solution architecture for say land records, another one blockchain solution for healthcare, and they are quite different. Their assets that are involved are quite different. The transactions are quite different. Some have multiple channels, some require single channel. The REST APIs for accessing, making transaction requests and so on are quite different. So privacy requirements are quite different. So it makes no sense to build a blockchain, have nodes all over the state or region or the country, and say that okay, here is a blockchain, now you can build an application on top of this. It doesn't make sense. Each application needs to be considered in its entirety, and what blockchain solution works for it will depend on the problem, its requirements, and then accordingly you have to create the solution. And there are multiple different platforms that are available. Most of them are open source, so there is nothing hidden in there, and you can always use them to build your application. So this concept that we build a statewide blockchain or nationwide blockchain and then any kind of application will be built on top of it makes no sense. Second misconception I keep hearing is that blockchain is secure, which means that they assume that tamper resistant data repository is same as secure. But we have seen in this course while discussing, for example, the Ethereum, for example, as soon as smart contracts came in, the number of vulnerabilities that were exposed were very large, right? And we discussed some of the tools that people have developed to check the smart contracts for security vulnerabilities and so on. So blockchain by itself, by definition or by construction, is not secure. What blockchain guarantees is that if you have a proper mechanism for transaction validation, if you have a proper mechanism for building consensus, then you can create this chain of blocks, and then when the chain of blocks is sufficiently long, then building going back and changing one information or more information in a particular block is going to be so computationally expensive that you can assume that it is going to be almost impossible, computationally almost impossible. So therefore you are going to see data integrity. Now in case of blockchains that are not based on, let's say, proof of work kind of consensus mechanism where the computational cost is not prohibitive, but they have probably something else, for example proof of authority or proof of stake, where somebody, unless a large number of high stake individuals in the blockchain participants don't collude and want to attack it, the integrity cannot be easily tampered with. In case of permissioned blockchain, it is secured by way of the fact that identities of each participant is actually established, and therefore any kind of tampering attempt will be actually figured out, because of the because it will take long time to actually go back in time and redo every transaction except the transaction that you want to say eliminate, and then and not get caught, because your true identity is associated with that identity. So so security so integrity is something that is kind of part of the reason why blockchains are used, but doesn't make it any secure. For example, against DDoS attack, against exploiting software vulnerability in your smart contracts to do things which would be otherwise considered from the blockchain's perspective. This is legal because this is acceptable because transactions are going through according to the smart contract and everything, but the smart contract itself had the bug, and therefore somebody is using it to do the bug. For example, in the DAO attack, they used a bug in the security in the smart contract that allowed somebody to change the owner of an account, and that's why the attack could happen. So declaring that since I am doing blockchain I am secure is also a very wrong idea. Now another misconception is that since I am using cryptography, no matter what cryptography I am using, it guarantees that the blockchain data integrity is kept. Now this is again depends on the cryptography and the strength of the cryptography you are using. Of course, if you are using a cryptographic hash function, for example, that is so far known as collision resistant, like SHA-256 or SHA-3, you can be more or less feeling comfortable about the data integrity, but we don't know in the future. Nobody would come up with a way of finding collision. Like SHA-1 was considered pretty secure. MD5 was considered secure, was used for some time, but then people found ways to do collisions in them. Similarly, cryptographic signatures, because you are using RSA, for example, or some other public key cryptography, you can assume that if you are using the proper key size and everything, it is not possible to forge signatures. But we know that RSA 10 size of 1024 bit long keys are no longer considered very secure. Also, there could be other things like side channel analysis on your machine, on which you are doing the cryptography, and then the private key may be leaked out. So all kinds of possibilities are there. So you cannot you cannot completely guarantee that cryptography is going to keep the data valid and data integrity intact. But if you are using strong cryptography, strong hashing function, collision resistance hashing function, for now you are okay. The other issue is that quantum computing. So in the future, if the data is kept for a long time, if a particular blockchain is there for a long time, and then and then the keys are still using, let's say, RSA, and even the PKI is RSA, then if quantum computing becomes a reality, RSA will be broken, and then you will have a problem. So all these things has to be always considered in the context of current time and what is best known about the cryptography you are using at the current time. So another one I heard is that from the government agencies, that government must design a blockchain on its own and force every government organization to use it, use that implementation of the blockchain. So this actually was told to me by some government people, saying that we want full control on the blockchain that people are using for e-governance. We don't want a foreign provenance blockchain. We don't want a freeware or open source blockchain. We want to have our own, and therefore we have everybody will have to force everybody to use it. One example they were trying to give in support of this argument is that look at what WhatsApp has done to us. We have no way to force Facebook to give us the messages that are being exchanged on WhatsApp, so we should not be dependent on technology built by others. But this is a very wrong idea. The reason being that you cannot have a untrustworthy system to create people's trust. The whole point of doing blockchain based e-governance is to actually earn people's trust in a much better manner. Now if you say that I am going to build a blockchain, I am going to build the cryptography in it, I am going to have full control of the code, and I want security by obscurity, then you are going to be in for a surprise. First of all, people might suspect that the cryptography has been weakened, or some form of some backdoor is there in the infrastructure for government to actually get the information before cryptography is applied to some data, or before hashing is done on data. That's one problem with respect to generating citizen trust. But the other issue is that indeed it's not something that government should control. So same kind of misconception is that it has to be a government vetted closed source blockchain platform to develop all e-governance solutions. Same thing, but the other problem is that there are multiple different varieties of blockchain, right? So we have seen blockchain has evolved from blockchain 1, blockchain 2.0, blockchain 3.0, and now we are talking about blockchain 4.0. So this thing is an evolving technology. If you make it a closed source blockchain now, today, then tomorrow the blockchain will move to much better features and better ways of doing building applications, and then you will be missing out. Second problem is that where will you get the best programmers that are working on Ethereum or Hyperledger, because these are open source and huge community of very good programmers are developing them. Where will you get that kind of developers in the government sector to build something that competes in performance, competes in feature set, competes in the ability to provide the guidance? Everything is going to be difficult. So it's best to do open source blockchain platform. Because it is open source, you can have the full authority and ability to actually look into the code, look for existence of any backdoor, check the cryptography implementation, everything, right? So it's not a good idea to have a government weighted closed source blockchain platform for e-governance solutions. Another misconception I keep hearing is that, oh, blockchain is an open ledger, it's open to everybody, so there will be no data privacy, and that's again a wrong idea. First of all, you don't have to put the entire data on the blockchain, even if it is open and public. You can put the hashes of the data, because eventually you want to use blockchain to provide data integrity guarantees, and not to float the data itself. In case you want to have the data transferred, there may be other ways to have the data transfer rather than using the blockchain as a conduit for data transfer. So it's not a total misconception, or maybe the mindset that is stuck in blockchain 1.0, like Bitcoin or Ethereum, where all the data is available to everybody in their public permissionless setup. Then I can understand that that misconception has arisen of that. But people should study the latest blockchain technologies, the distributed ledger technologies, and get rid of this misconception. So the other misconception is that a right to forget in data privacy law is incompatible with blockchain usage. So this is again the same kind of mistake. First of all, you don't put the data into the blockchain if there are personally identifying information or other kind of information that comes under the purview of the privacy law. So secondly, the data has can be a particular in a permission blockchain, a particular change in the data is possible by basically making a transaction for doing that. So therefore, two things. One is that you don't put e-governance blockchain in public permissionless setup. So therefore, there is only permissioned entities that are going to look at the data. But even if that is a concern, you actually can put encrypted version of the data, and this encryption has to be strong and forward secure, which means that it should be encrypted with a quantum resistant cryptography. And then there may be proxy re-encryption scheme and other schemes to actually for the data principal to release the right to look at the data. And then once your data has to be forgotten, then you actually destroy the ability to create a re-encryption scheme, re-encryption keys. So also in some cases you only put the hash of the data, in which case there is no concern about this right to forget, because there is no way to reconstruct your data from the hash. So again, this is a mindset that's coming from knowing only about Bitcoin and maybe Ethereum, but this mindset has to change, because now we are far we have come a long way from Bitcoin type of blockchain to distributed ledger technology, and where this kind of concerns can be easily addressed. Another issue is that, so if you put something in the blockchain, you don't know where it is the ledger is replicated everywhere, so there is no guarantee that the data will be localized in the country, whereas government requires that all the data should be localized in the country, which means that all the data should not leave the country's geographical boundaries. All servers in which data is kept should be within the geographical boundaries of the country, because the data may be subpoenaed by the courts of the country, and if it is in another country, it cannot be done, it cannot be subpoenaed by the extant laws of the nation. All these considerations are called data localization considerations. Now if you are using a hyperledger instance or a coda instance or some permissioned private blockchain for providing e-governance with the proper APIs for people to access data, but through certain nodes that are exposed, that are exposing the REST APIs, then all the servers and everything are under your control, under the control of the government. So there is no no concern about data localization. So this is again another misconception that has to understand how the permissioned private distributed ledger technology works, and then this misconception will be addressed. Another misconception I heard a lot is that the government must have a regulation to regulate the technology. Now that's actually again a misconception. You don't regulate a technology. What you regulate is the rules. What you regulate is how the data is used or how transactions take place. So it's not the underlying technology that you need to regulate. You need to regulate the particular application domain in which, if it is banking, then the banking regulations. If it is legal contracts, then it is the company law or whatever the applicable laws are, has to regulate that particular application. Now, one situation is certainly important is that, for example, our transactions that is done over an IT system and without any manual intervention, legal transactions, our contract made on an IT system without manual intervention are acceptable, or are proof of tamper that one can generate from the blockchain, the investigation into a blockchain, is that acceptable in a court of law in the country? These kind of blockchain related the changes in IT law or IT Act associated with taking into account that the usage of blockchain at various sectors has to be made. But that is not about regulating the blockchain technology. It's about making laws more amenable for broader use of blockchain technology. So that's a facilitator of developing applications on blockchain technology rather than regulating the blockchain technology. Regulating blockchain technology would mean that you go and tell that you cannot use this kind of blockchain technology in this kind of applications. You cannot use permissioned blockchain for this kind of applications, or you have to use permissioned blockchain technology for this kind of applications. Those would be regulating the technology, but that should be left to the particular domain and particular maybe government agency who would be using this, and assuming that they are doing the right thing. There should be certain applicable policies related to security, related to privacy, related to availability, integrity, etc., and they have to choose the right blockchain technology for fulfilling those obligations. That doesn't, you don't have to actually regulate the blockchain technology. Then another prevailing misconception I heard a lot is that, oh, it's all about cryptocurrency. It is immensely power consuming, and therefore it's not environment friendly. Again, this kind of ideas are coming from the misunderstanding and the ideas that originated in Bitcoin or blockchain 1.0 with proof of work. We have seen throughout these classes that's not the only type of blockchain, neither are they really applicable to most of the applications that we really want blockchain to be used in, and therefore this concern is not a correct or valid concern. So with that, I would like to close this week as well as the course. I am hoping that this course has given you a very good conceptual understanding of the blockchain technology, its evolution from blockchain 1.0 to 3.0, and the various ways the blockchain has evolved for making it applicable for various applications, what a blockchain technology based application give you, and what are the advantages of using that particular uh, uh, application over a blockchain rather than a traditional centralized IT system. Also, I hope that you understand the prevailing misconceptions regarding blockchain and how to dispel them. And finally, I hope that by understanding at least 5 different blockchains in some details, like Bitcoin, Ethereum, Hyperledger, Coda, IOTA, and having very cursorily seen something like the Algorand kind of application, kind of blockchain, you have some idea that this field of blockchain technology is quite has quite a bit of variety, and because of this variety, it is able to uh, it is able to fit into various different application domains, and which application domain actually requires a blockchain based solution depends on what are its requirements in terms of data integrity, in terms of availability, in terms of redundancy of data, in terms of who is allowed to participate, and in terms of whether the data that is kept in this decentralized ledger should be visible to everybody or not. All that considerations has to be factored in before you choose whether to first you choose whether to really use blockchain, or centralized system is sufficient for your requirements, or if it is the blockchain that you want to do, then the question is what type of blockchain you need to use. So this kind of conceptual understanding is what the goal of this course was, and I hope that having gone through 8 weeks of lectures and quizzes and all that, you are now comfortable and confident about that kind of abilities to advise as well as select yourself the right approach to developing an application with blockchain. With that, I wish my best to all of you for a more productive career in using blockchain technology, in case you decide to do so, and for that also you have to learn more about at least 1 or 2 specific blockchain technology in detail, how to build applications in those blockchain technology, and how to deploy them, how to maybe deploy them on the cloud, these kind of things that you have to figure out over time. And hopefully this course was a suitable substrate on which you will be building a much more robust castle of knowledge, which will give you advancement in your career and your studies and research, whatever is you are doing. With that, thank you all for listening for 8 long weeks, and wish you all the best. Thank you.